Ah. Morning, can y'all hear me? Can you hear me? Hello? I guess not. Oh, good. Okay. Let me see. Okay, type your name in the chat. And I got on campus just minutes ago, so I'm still gonna be setting things up. And someone left the camera on. That was a big no-no. Let's see. There it is. It's just I couldn't find it again.
The camera not working up there?
No, it's working. I just didn't have the remote to it
Oh, okay.
on Monday, last
Yeah.
Monday. But it was in there. It was just hidden. So
Oh,
I didn't have to use my stupid camera. Let's get in here. And let's turn this on. And I have to minimize those screens so I can go to where here.
this sign-in sheet for us?
Yes, I'll get that in one moment. That's not this class. Here we go. This is pre-count. When you sign in, please be sure and use your initials and a check mark. One of my other classes, they started doing check marks. I don't want check marks. I printed that up. I printed up with check marks because it's already happened. So. And I knew I had to change this setting. I don't want to duplicate. Where is it? There it is. And we were getting into trig functions, right? We did that basic graphing. And here we did secant, we did tangent, cotangent, secant, and secant. Or had we just started that? Yeah, I don't think we had done secant, cosecant yet. We did tangent and cotangent. So that I'll start with that section. Don't forget to sign in before you leave today. I have not started grading the exams yet, so if you haven't completed homework assignments up to 6-4, you still have time before I pull those grades.
When are you reading that?
Hmm?
When are you reading it?
Well, my lab grades it. And then I pull all those assignment grades and average them to determine what portion of 15%, 15 points gets added back to your test if you made under an 80. We go into the test. No surprises. The one on the review. One more device I need to grab. Give it a techno file. It is working. I'm gonna go in there and change that set. Oh, are there any questions from anybody about anything so going on so far before we continue on?
When did you say you're going to breaks from,
As soon as I'm done grading. And that'll be,
we have to have
I'll
section
start
6
grading
then?
today. What?
We have to have section, section
1 through
6
6, 1 through 4,
Okay.
because that's what was covered on the test. I noticed in the homeworks that in the previous section, they covered. They also did something like y equal negative cosine 3 pi plus ix plus 4 minus 3, something like that, where you had a number in here as well as a number out here. This is the phase shift, and we'll cover that a little bit. I don't think the homework and the textbook are synced up as well as I thought. All right, graphs of the tangent, cotangent, cosecant, and secant. Tangent, I think we covered very briefly. And same with the cotangent. Cotangent and tangent are reciprocal functions. They look very much alike. Their domains are shifted a little bit. And then the graphs of secant and cosecant, they look an awful lot alike. And they also are shifted a little bit from each other, just like sine and cosine look the same, except they're shifted by pi halves. So they have a phase shift. But tangent and cotangent, it's more of an inverse relationship, but it's also a phase shift as well. This is a graph of tangent with a restricted domain, because we know at pi over 2 and negative pi over 2, tangent does not exist because you're dividing by 0. So this is what the graph of tangent looks like. The 3 key points here, well, yeah, the key points here are now negative pi over 4, negative 1, pi over 4, 1, and the asymptotes negative pi over 2 and pi over 2. Each of these asymptotes are a multiple, an odd multiple of pi over 2. And the range is all real numbers, because it goes down forever and up forever, and those values are repeated infinitely. So this is how they state the domain, is that it's all real numbers except x not equal to the multiples, the odd multiples of pi over 2. All right, the domain is a set of all real numbers except odd multiples of pi over 2. The range consists of all real numbers. The tangent is an odd function. So if we look back at this graph and we just look at the primary period, you can see that this point and this point, the difference between the two is that both are negative and this one's both are positive. This point over here and this point over here are going to be negative. The x and y will be the opposite signs, because they are symmetric with respect to the origin. And that's what that means here. And so every point has an opposite. If you add the x's and the y's together, you get 0. 0. So that's what happens there with odd functions. The tangent function is periodic with a period of pi. Right? And the periods fall between the vertical asymptotes. And the vertical asymptotes are the same as what's excluded from the domain, because the function does not exist at those values. So we have a vertical asymptote at those values. And the x-intercepts are multiples of pi. And the y-intercept is 0, which is also one of the x-intercepts. So the point 0, 0 is both an x and y intercept. Now for cotangent, Cotangent is the reciprocal function of tangent, so you flip the numerator and denominator. So where this function does not exist at these odd multiples of pi halves, at the multiples of pi halves is now at 0. So the multiples, odd multiples of pi halves is part of the domain. And since it's a reciprocal function, the zeros are at the multiples of pi, so that means with cotangent, those don't exist for cotangent. So notice they didn't show 0 or pi. Because at 0 and at pi and at 2 pi and 3 pi and negative pi and negative 2 pi and negative 3 pi, you have vertical asymptotes. Because the function does not have a value at integer multiples of pi. And guess what, we should technically throw in integer multiples and not multiples and not just multiples. So this too is an odd function. Because this point here and this point here, you change the sign on this point, you get this point. You change the signs on this point and you get this point. So they are symmetric with respect to the origin. You don't give the properties here. Okay. So here's never did like graphic tangent, cotangent, secant, cosecant. But yeah. So use the graph to determine the domain and the range of 3/2 tangent plus 1/2. All right. This 1/2 here is a vertical shift. So it shifts the graphs up, all the y values up 1/2. But before we do this, which is a vertical stretch. So we're pulling it away from the x-axis because 3/2 is greater than 1, then it's a stretch. So let's see how they do it. So the first thing they did was they did the vertical stretch by multiplying the y values by 3/2. So this -1 became a -3/2. 0 stays 0, and this 1 became 3/2. And so everything got pulled away from the x-axis. It's not much of a stretch, so it's kind of hard to see that it's being deformed, but it is, because the scales are the same. And actually that's not 3/2, but maybe it is. So this point got moved up to here. And this point got moved down to here. It got pulled away from the x-axis. And then the next thing they do, they're going to add 1/2. So they're going to add 1/2 to a -3/2, and they're going to add 1/2 to 3/2. And so all these at 3/2 get moved up 1/2. And all of these at -3/2 get moved up 1/2 to -1. These got moved up to 2, and these got moved up to 1. And then the 0 here got moved up to 1/2. And that's what they did for that class. Okay. Now, the domain, they asked for the domain. Well, the domain of this function is the same as the domain of tangent, because nothing was done to change my x. The omega is 1 and there's nothing being added in there. So there's no change in the x direction. So the domain remained the same, which is all real numbers except for odd multiples of 5. All right, and they wrote it this way. This is a more traditional way of writing it. You'll see them use K an awful lot when you get into calculus and other mathematics courses and into engineering, I think there's it as well. They use K, and then it's usually an integer, K or I or N. Those are the three variables they use to denote an integer or a scalar or multiplying by a number. And I usually write it differently. I usually write it as putting the K out over here. It works out the same way. If K is 2, then be 1/2 pi times 2, which is, well, if it was a 3, it ended up being 3/2 pi, or 3 pi over 2. And then the range still stays all real numbers. Just because I moved it up or down or stretch it out, it was still going to infinity in both directions. Cotangent. Well, the range of cotangent that won't change, because we're still going to be going into infinity directions. And so we look at the graph of cotangent, and because the function, we have this change. Oh, let's see which one did they do first. Yeah, they did the vertical stretch first, and then they did the compression. With omega equal to 2, our omega equals 2, so that means our new period is going to be 2 pi over omega, which is 2 pi over 2, which is pi. So this was a compression. No. I'm sorry. The period for cotangent is pi. So now it's going to be pi over 2. The 2 pi was for sine and cosine. Pi is for tangent and cotangent. And so we divide that by omega, which gives us pi halves. So instead of being in here, now it's going to be in here. So everything got shoved towards the y-axis. And same thing on this side, we got shoved towards the y-axis. We're increasing the frequency. And that's what they show. Well, first they showed the vertical stretch by multiplying each of the y values by 3. 0 stays 0. But now -1 came down to -3. +1 came up to +3. So that's what happened to those points. And so in between, it almost looks like a straight line, but it isn't. And then the next thing is to look at I wish they would have continued this picture over to this slide as well. replace the x by 2x, you get a horizontal compression of 1/2 pi. So inside of the period for cotangent of x, you have 2 periods of cotangent 2x. And then this just repeats again and again, that way and that way, in the positive direction. And this way and that way isn't a very definitive direction. Okay. So the domain, all right, the domain instead of every pi, now it's every pi over 2. So it's all multiples, integer multiples of pi over 2. Which is this way of saying. K is an integer. So it and again I would write it this way. Because when k is 0, then this is not in it, and then when k is 1, and when k is 2, and when k is 3, you get 3/2 pi, and then the negative as well. And the range stays all real numbers. Now this is a graph of cosecant. It is superimposed on the graph of sine. When sine is 0, that means cosecant does not exist. Because cosecant is 1 over sine and 1 over 0 is undefined. So cosecant does not exist when sine is 0. And sine is 0 at multiples of pi. Integer multiples of pi. So at integer multiples of pi, the function does not exist, so that's not in the domain. And that's what they're saying here. The range negative infinity to infinity, where x is not an integer multiple of pi. And how they would state that in Set Builder. Fine. Oh, those online can't see me writing that. Sorry. The set of all x such that x does not equal ik or k pi. I'm used to writing that afterwards, but k pi, k is an integer. And then here the range, well, because it's a reciprocal of sine, that means all these values which are less than 1 become greater than 1. These are greater than 1, so it's going to become less than 1, so it's going to become greater than 1. And all of these over here are greater than -1, so it's going to become less than negative. So y, the range is all real numbers such that y is greater than or equal to the absolute value is greater than or equal to 1. So that means then if there's a void between -1 and 1, those y values do not exist for cosecant. And the same for secant. So yeah. So you notice that the graph for cosecant and the graph for secant look very much the same, just like the graph for sine and cosine look much the same, except they're shifted. So the range is going to be the same, but now the domain has been shifted because where sine or cosine is 0 is at the odd multiples of pi over 2. So that means the odd multiples of pi over 2 will not be in the domain. So similar to this, but it's x such that x is not equal to pi over 2k, where k is an integer. Oh, an odd integer. Because that whole value is of pi, it's at -1 and positive. So that those graphs will kind of funky. So to graph this, here we have a vertical stretch and a vertical shift. Bam. Since the -1 brings all the y values down 1 unit, but before we do that, we're multiplying each y value by 2. So they multiplied by 2 first. So -1 went down to -2, and +1 +2. And then they subtracted 1 from each of those y values. So this part got moved down to here, and this part got moved down to here, and it continues on. Questions there? You were thinking in math, in college algebra, when you were doing transformations, that thank God that's over, right? No, it's not over. Okay. The domain of all right, the domain. Did the domain change? No, the domain didn't change because omega was 1. Okay. Omega was 1. It was just a cosecant of that. So our domain didn't change. So our domain remained with 1 was cosecant. That was it. Which is what they have here. Oh, okay. Okay. Oh, this was secant. Secant was the second one. All right. I'm used to doing secant before cosecant. That's how I always taught. So that's my prejudice that I was doing secant first. And then the range, because we changed our -1 and 1 by multiplying by 3, now it got shifted, and then we moved it again. Okay. So we did 2 things. Okay. We shifted our -1 and 1, and then shifted those down 1. So now the -3 is the highest on this end, and 1 is the lowest on this end. So it's from -infinity to 3, including -3, and it's from +1 to infinity, including 1. And that's what they're saying here. So if you were to do it in set builder, no. Is that y has to be less than or equal to -3, or y has to be greater than 1 or equal to it. And that's what these 2 intervals are showing. And we use the union between those 2 sets to say that it's in one or the other. And by this point in time, you haven't learned very much about set notation, have you? Or about sets. That's a whole different ball. That's what killed me first time I went to college. I started out as a math major, and set theory blew me out of the water. Not because it was hard, but because I wasn't ready to learn it. And because it was using language I was unfamiliar with. And that was my issue, not the issue of the course. So that's how I became a geology. Worked out in the oil fields for 9 months and decided that's not what I want. When I was 35, I was ready to go back to college. Didn't we just do that? How come this is repeated? I'm gonna have to go through this and look again and update the files on. Put it in there twice. Oh my God. Must have been late at night when I was doing this. Okay, now phase shift and sinusoidal curve fitting. The sinusoidal curve fitting is you have a problem and now you want to come up with an equation that fits that word problem. I call them application problems, but it's when I first started teaching 30 some odd years ago, they were doing the transition from calling them word problems to applications. I still haven't made the transition. Okay. So the graph of sinusoidal equations. Okay. Where now we add this thing. This is a Greek letter P. Not to be confused with the number 0. Because I know a lot of people, especially in the military, write their zeros as well. This is, and it's pronounced P. So now we have 2 Greek letters, omega and Phi. There's another Greek letter that we use sometimes. I don't think we'll use it in this class. Looks like this, usually written that way. And that's psi. Psi. Like psychology. I mean, not psychology. No, wait, I can't even do it anymore. All right, it'll come back. But we won't see this in this course, I don't think. All right, and so let's move on. Now for the graphs. And please notice that this is a minus sign here. So when they ask for what phi is, right, or the phase shift, it's whatever that number is being subtracted. So if you have something like 3x plus 7, then that means phi is a -7 because minus a -7 because we're subtracting what phi is. So that's something to be aware of. And that means that's a horizontal shift. That means we're shifting our X values by -7 units. Or actually by -7 over omega units. So omega is a very important number. If omega is less than 0, then it's a shift to the left. If omega is positive, then it's a shift to the right. Yeah. Just like when we were talking about phase shift with, the horizontal shift with parabolas. If we have x minus 2 being squared, that means x squared went from over here to over here. That moved over 2 units to the right. Because what I'm subtracting is a positive number. If it was x plus 3 squared, then that means it got shifted 3 units to the left, because that's a -3 we're subtracting. So whatever the sign is in here, it's the opposite. So that's how it comes up. So you have the amplitude, which is the absolute value of A. You have omega, which helps you determine the period. And you have phi, along with omega, helps you determine the phase shift. So the phase shift is just the horizontal shift. Where omega here is a horizontal compression or stretch. So you still have those going on. It's just they're more prevalent in the sine function than other functions. Amplitude, find the amplitude, period, and phase shift. So the amplitude is the absolute value of 3, which is 3. The period, well, first thing to identify here is what is A, what is omega, and what is phi. So omega is 3. A is 3, omega is 2, and phi is pi. So the period is 2 pi over omega, which is 2 pi over 2, which is pi. And what is it? Do they use a letter for phase shift? No. So phase shift is phi over omega, and phi is pi, and omega is 2. So the graph is shifted 1/2 pi to the right. Hang on a second here. Okay. So we're going to use a 4-step process here. Oh, I see what they do. This is good. Okay. So the next thing they do here really helps things out as far as these 3 things and these 2 are concerned. Because what they do, they're gonna factor 2 out of these. So you have 2 times x minus pi over 2. Well, with the pi over 2 is what we got for the phase shift, because we're factoring the 2 out of this. So, and yeah, they say note that A is 3, omega is 2, and B is pi. And so this is our phase shift, which is right here. And this is omega, and then A. So this little act of factoring out the coefficient of x tells us what P is, what the phase shift is. Sorry. And the numerator is what you're subtracting is P. Some people pronounce that as phi, but I've always heard it called P. So to do this, and we already discussed this, that the period is pi. It's dividing 2 pi by 2 gave us the pi. The phase shift we found by either doing it this way to find that phase shift, or to divide P by omega, you get the same fraction. Now I'm hesitating here because I don't know which way they're dealing with. Okay, so the graph lies between. All right. The A tells us the highest and lowest of the. Since there's nothing being added here at the end, that means our range isn't going to change beyond the vertical stretch. So that means the 1 and the -1 go down to -3 and up to +3. So now my range is from -3 to 3. So that's telling me how high and low it's going to go. Now all we need to know is what's happening with the period. So I always look to see what happens to my 0, 0. Because right now, sine, I'm just going to look at the primary period, first period. 3. So it goes like this. Right? But I'm shifting it half a pi. So I'm shifting the x values half a pi that way. So this got moved over to here. I have a friend who teaches in Harlendale, and if he can't use 8 different colors while explaining something, then something seriously wrong. 3 colors is so they got moved over to here, and this one got moved 1/2 pi over to here. This
this got moved 1/2 pi to here. And this got moved 1/2 pi to here. And this got moved, what is that? 5 pi over 2. So now it goes like this. And now we're gonna look at the compression. The compression is multiplying each x values by 1/2. Because theta over omega is how we're changing each angle. We change the period the exact same way, because we're changing the angle to pi now to the angle 5 pi over 2. But now we're going to change 5 pi over 2 and 3/2 pi and 1/2 pi. We're going to change those by multiplying by 1/2 1 over omega. Because now we're going to take the angle and multiply it by 1 over omega. And since omega is 2, that's 1/2. So 2 times 1/2 is 1/4. So this comes down to pi over 4. 1/2 times pi is pi over 2. So this got moved back again to here. So that got moved over to here. This one got moved back. Actually got moved back to its original position. We're going to take half of this, so that's going to be 3/2 pi times 1/2, which equals 3/4 pi, 3 pi over 4. And so that's right here. So this gets shoved all the way back here. Remember, it's a compression. So we're making it everything happen faster. And now this point here, which is at 2 pi, we're going to multiply 2 pi by 1/2, which gives us pi. So this point here gets moved all the way back to here. Wait a minute, I didn't, 3/2 pi. That's this point here gets moved back to here. Okay. So it wasn't this point I was moving. It was this point I was moving for. Oh yeah, the 3/2 isn't moving, it's this one. That moved back to here. This one got moved back to here. Yeah, it's the one in black I'm moving now. And so this one gets moved back. So 5 pi over 2 times 1/2 is 5 pi over 4. So that's right here. 5 pi over 4. So this point got moved back to here. This point got moved back to here. This point, where did it move to? No, that wasn't the point I was moving. Oops, sorry. So now it goes from here up to here. Okay, yeah, this point did get moved back to here. And this point got moved back to here. Okay. Oops. So I did this on the graph. If I did it using the key points, whereas the sign, the key points are 0, 0, pi over 2, 0, pi over 2, 1, pi 0, 3/2 pi, -1, and 2 pi 0. So the first thing I did was my vertical shift. I mean, my phase shift, which was adding the phase shift, which is 1/2 pi, to my x values. So that became 1/2 0, and that became 1/4 pi 1, and this became 1/2 pi 0, and this became 3 pi over 4 -1, and this became pi. No, I'm adding. Right, I'm adding 1/2. Adding 1/2. So that became pi. And this became 5/2. Oh, 3/2. Adding 1/2. Adding 1/2. So that became pi. And that became 3 pi over 2. And that became 2 pi. And that became 5 pi over 2. Okay. Okay. Get it wrong. So I was thinking multiply. I don't know why. I'm adding 1/2. And now, with the period, I'm going to be dividing by pi over 2. I'm going to be dividing by 2, which is multiplying by 1/2. So I'm multiplying each x value by 1/2. So this becomes pi over 4. This becomes pi halves. I haven't done anything about the y values yet. So this becomes 3 pi over 4. And this becomes pi. And this becomes 5 pi over 4. So this was adding 1/2 pi. So I did plus 1/2 pi. I'm adding 1/2 pi to each x. Now I'm multiplying each x by 1/2. So I'm multiplying each one of these x's by 1/2. Where here I'm added 1/2 to each x. And now I'm done changing the x values. Now I'm going to change the y values by multiplying by -3. So it's, by 3 times the y values. So that's going to be 1/4 0, 1/4 pi, 1/2 pi 3, and then 3 pi over 4 0. The zeros aren't changing in this case. And so this becomes pi -3. And this becomes 5 pi over 4 0. And so that's what these points are. This is pi over 4 0, 1/2 3 pi, 3/4 pi, yeah, 0 pi -3 and 3/4, 5/4 pi 0. So I got to the same points, just in a different manner, but I'm doing the changes the same way. I could have done the stretch here at the first. Because when I do the stretch, does not affect doing the compression, the vertical stretch does not affect the horizontal compression or shift or phase shift. It's a horizontal shift, but when we're talking trig functions, it becomes a phase shift. So a phase shift is the same as a horizontal shift. Blame that on electricians, okay, and physicists. On Star Trek, a phase shift is not a good thing to do. Okay. So the cycle, one cycle begins at pi over 2, and ends at 3 pi over 2. No, I don't see that. Oh, I see the problem here, because that should have been 5 pi over 2. That should have been 3 pi over 2. So that would have been 3. So I had it right on the graph, I just had the wrong number. But that doesn't take into account the compression of this. So the 5 key points. That's with the shift. But they didn't deal with the compression. So you multiply by 3, replace with, so then you have a compression. And then you have the shift. So I'm not seeing how they've got the compression in there. So they just have the phase shift in there. That's all I have is the phase shift. Right, this was the compression. So it went from here to here to here to here. There's the compression. And then they shifted it by half a pi. So what I do wrong? What would I do different? Because when I have 3/4 pi, I'm at 0. So they throw in the phase shift last. I guess makes sense. First they do the compression and then the phase shift. So cosine, it's 0, 1, and then half pi 0, and then pi -1, and then 3/2 pi 0, and then 2 pi 1. They did the stretch, the vertical stretch, which is 0, 4, half pi 0, pi -4, 3 pi over 2, 0, and 2 pi 4. And now they're going to do the vertical stretch, which is a -1. So now it goes from 0, 3 pi over 2, -1, because 0 - 1, and then pi -5, because -4 - 1, and then 3 pi over 2, -1, and then 2 pi 3 again. So that's just the cosine function being vertically stretched 4 units and then brought down 1 unit. The next thing they would do is the phase shift. I mean, the period change. So now it goes from 0 to pi, because 2 pi divided by 2. And so here we have half a pi, and then 1/4 pi and 3/4 pi are our 5 x values now. So I change my x value by replacing them with 0, 1/4, pi over 4, pi over 2, 3 pi over 4, and pi. So this point didn't change. This point went down, went closer to the y-axis. And this became that. And this is 3 pi over 2. And this is pi. Now, rewriting this as 4 cosine 2 times x plus 3 pi over 2. which means that the phase shift is a negative 3 pi over 2. So I add a negative 3 pi over 2 to x, each x value. Or I subtract it, if you want to look at it. So this is going to be a negative 3 pi over 2. And so, and 3. And so we have a negative 3 pi over 2 plus pi over 4. So that's going to be a negative 6 pi over 4 plus pi over 4, which is a negative 5 pi over 4, negative 1. Oh, okay. And then subtracting 3/2 from this is a negative pi. Negative 5, yeah. Negative 5 pi over 4, and then a negative pi. And then, yeah, each one is a fourth of a pi, so this is going to be a negative 3 pi over 4. Actually, this should be 0. Oh. Zero minus, and then pi over minus 3 pi over 2, 6 pi over 4. That's a negative 5 pi over 4. And pi over 2 minus 3 pi over 2 is pi. Actually, it's negative pi. Oh, that's supposed to be a 4 here. That's why I was confused. So now I have 3 pi over 4 minus 3 pi over 2, which is 3 pi over 4 minus 6 pi over 4, which is a negative 3 pi over 4. And then another half pi is going to be a negative pi over 2. Because pi minus 3 pi over 2 is half a pi. And so these are the key point, where the key points wind up. And I'm not going to graph this, I'm going to let you see how they do it. And so, yeah. So phi, this is phi, which is a negative 3 pi over 2. Omega is 2. Alpha, A is 4. And our vertical shift is a negative 1. They didn't have plus B here on the end. So B is negative 3 pi. Yeah. 3 is a negative 3 pi. So the phase shift is negative 3 pi divided by omega, which is 2. So the period is pi, and the phase shift is negative 3 pi over 2. And the graph, so the range will be from -4 to +4, which is what happens here, because we've changed our, well, That's before the -1. Because now it's from -5 to +3. Because of the -1, this -4 to 4 become -5 and 3. So they're looking at it before they do the vertical shift. Okay, so the 5 key points. Yeah. One cycle begins at whatever the phase shift is, that's where it begins. Because it's going to be 0 plus the phase shift. In this case, it's a minus. So it shifted back. It shifted back to -π/2. And it runs up to -π/2, which is what I have here. And so they went ahead, all right, so they found out where it began and where it ended, and then divided that interval into 4 subintervals. And so they found that the difference is π/4. So they added π/4 each time to find the values for x. So 3/4, 3/2 pi, and then they got -5/4 pi, and then they got -pi, and then they got -3/4 pi, and then the -π/2. So they got these points, but with the original shift, stretch value. So that would be 4, 0, -4, 0, 4, which is what they have there. And then they throw in the -1. Now they throw in the -1. They didn't do the -1. They did not do the -1. Well, let's add to the confusion that I'm already causing, okay, guys? Fucking hell. This pisses me off. I have a hard enough time explaining this without them doing this kind of a screw up. So instead of being up there, it's here. That's going to be here. And that's going to be here. That's going to be here. And this is going to be here. So it goes like this. So this whole thing would be shifted down 1 unit. So the highs are now here, 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 and the lows are now here, here, and here. And these points got moved down 1 unit. And you know what? I didn't look to see what the next line was going to be. There they did it. There they did it. They did the shift. They did the vertical shift. I didn't realize there was another slide. Although I should have kept track of. They tell you how many slides are on in the particular exercise
For example.
My rules on this. So now they're talking about fit the sign function to the data. One way to do this is to find out where is where's your x-axis? The x-axis may not be on 0. So the x-axis is supposed to be halfway between the low value and the high value. So you look at the high values here. The highest is 72.5. And the low values, well, there's 30 at 30.7. So I would take the average of those two, which is 30.4. And so 30.4 and 72.5 gives me 102.9, and half of that is 51 point what? Made that mistake on the test, that would have been a -1. So 52.3. And so right now I have sine of x plus 52.3. So when x is 0, then it's at 52 degrees. And then sure. It may just need a new battery. Okay. Well, let's go through their steps because I don't mess it up. So they look at the scatter diagram. So the scatter, I call this a scatter plot. And so this would be sine with the we're talking about through here somewhere. And that means this, we got a shift this way and a shift this way. So we have a phase shift and we have a vertical shift. Because sine is at 0 when x is 0, sine is 0. Let's look at it. Define the amplitude, compute the largest value minus the smallest value. So in this case, it's going to be 30.4 being subtracted from 42.2, which gives us 43.8 divided by 2, which gives us 21.9. So the A, or the amplitude, is 21.9. So we know what A is. That wasn't 30.0.4, it was 30. Where's that 0? So it's 22.1. So to see the remaining steps of the process, superimpose the graph of the function y equals sine 2.2.1, where x represents the months on the scatter plot. So what happened? So we had a shift, both in the horizontal and the vertical. So we had a phase shift and a horizontal and a vertical shift. We had an and we had an amplitude change. Okay. Needs to be shifted vertically, shifted horizontally, which is the phase shift, and stretch horizontally. Okay, so they're saying that the shift is this, there isn't a shift, there isn't a stretch this way, there's a stretch that way. Well, I can see that. Because they're saying that this point here is analogous to this point down here got moved up to here. So that's the shift vertical and horizontal and the stretch. Because now this point here got moved over to here before it got shifted up. So determine the vertical shift by finding the average highest and lowest values. And that's what I did. Highest and lowest values. And, oh, the average. So dividing by 2, so that gives us, yeah, that's right. Okay. I see that. And so that's going to be 26.2. Oh yeah, because that's supposed to be a 2 here. So that's going to be 4.2. That's 27. No, I had to divide this by 2. Okay. Which is what I got. Yeah, the 52.1. Okay. And so they throw that in there, and notice it shifted upwards, and then it so the high value matched this high value. And now it needs to be shifted horizontally and stretched forward. All right. So define the horizontal stretch back to first, since the temperature repeats every 12 months, then the period is 12. So omega is 2 pi over omega equals 12. So dividing, flipping both fractions, actually just switching the 12 with the omega. You get 2 pi over 12 is what omega is, which is pi over 6. So it got shifted pi over 6. Well, that's the period now. And so they throw that into the function and then graph it. So they're changing the graph each time to see what it ends up looking like. Okay, so I don't test you on how well you know how to use the calculator. So although this will be in your homework, it probably will not be, oh well, won't be on the test. I might have you graph, I will have you graph a function of this format, but I won't. I may not have you do this. There's a lot of work, a lot of tedious work, and a lot of things can go wrong here. Okay. To determine the horizontal shift, we use the period divided by n. So each length is pi over is 3. So there we have our 4 key points of interval. So from 0 to 3, it's increasing. From 3 to 9, it's decreasing. So the maximum occurs at 3. So the data indicated that the maximum occurs at 7. And so the graph of the function must be shifted 4 units to the right. So we're going to replace x with x minus 4. And so that means we're going to have pi over 6 times x minus 4. Yeah. Oh, what was out here? I forgot. We would multiplying sign by, and then plus the 52.1. And I forgot what A was. Oh, A was the 22.1. There you go. So, oh, and then they did the distributing property. So pi over 6 times that, pi over 6 times 4, which gives us 2 pi over 3. So phi is 2 pi. No, phi is 4. Yeah. And when they graph that, please notice that it does not exactly fit the data. But this is a model, and models predict, they do not accurately state. So at this time, at this month, the temperature should be around this. Well, it was actually down here, and so that's what they're saying here. Is that this particular function fits that set of data. So it approximates that set of data. from January to December of that year. So if you want to know what the temperature was approximately and halfway into this month, then it's approximately this temperature. So it won't be exactly that temperature, but it will be in a neighborhood of this temperature, plus or minus 5 degrees. Or 3 degrees. So determine A by taking the average of the smallest and highest, or the difference between the smallest and highest data. So that difference tells you how far apart those numbers are, and the amplitude is half of that distance. And then please realize that A could be negative or positive. But sometimes that might change. All right, and then the vertical shift is the average distance between the largest and smallest data. That average value gives you a vertical shift, how far you moved your zero. Move your zero, how much you moved your y values up or down that many points. So the period is t and the time the data takes to end up repeating. So in this case, the data took 12 months for it to start repeating. So the period was 12. So you divide 2π by the period, and you'll get the data. Determine the horizontal shift by using the period of the data divided for a period, or so you go from 0 to 20, in that particular data set, 0 to 12. So each subdivision is going to be 3 long. So it's going to be 3, 6, 9, and 12. So if we're looking at sine, then 3 it hits its maximum, and 9 it hits its minimum. And at the multiples of 6, it will be at 0. And then you determine what your phase shift is, like T over pi, P over omega, and you shift those values to the left or the right, depending upon what T is. Where are we talking? Oh, we're done. We'll get to this next time.
And I'll decide if we want to continue on with it. Any questions? All right, did I scramble your brains today? Yeah. Well, we'll turn it into an omelet by next time. So.
If you do not sign in, please sign in before you leave.
And in Zoom, if you did not sign in chat, please sign into chat before you leave. And we are done for the day. And that camera goes away. You too. Yeah, y'all take care. I'll see you on Wednesday. And I'm going to end the Zoom right now because I got to go.